page 3 has a couple of graphing calculator questions. Number 6 says the first derivative of f is given by this, the cosine of x all squared all over x minus a fifth. How many critical values does f have on the open interval? Alright, so a critical value means we're looking for when f prime is equal to 0 or does not exist. Alright, so we're on the interval from 0 to 10. You can see I've already placed the equation into the calculator in y1. And I want to graph this, but specifically from 0 to 10. So I'm going to hit the window button. I'm going to make my x-min 0 and my x-max 10. Right there. And now that we have that, I'm now going to hit zoom. Oops, let's try that again. Let's make that a 10. Zoom. There we go. And go to zoom fit. Alright, that'll put the graph on the screen, so I'll hit enter. And you're going to see the calculator's going to think for a little bit, or a lot of bit, and there it goes. Alright, and we're trying to see how many times it hits 0. Okay, and it's kind of hard to do that. Alright, there's not a lot of space to, we're trying to figure out how many times it's hitting the x-axis, so we got to really zoom in on that x-axis. So zoom fit gets us here, but that's not really the best graph. So we got to really zoom in on the x-axis. So let's hit the window button, and I'm going to actually go down and I'm going to make this similar to the y max. Right, the y min is really close to the x-axis. Let's make the y max the same, something similar. So let's go 0.2. All right, because that's really 0.2 right there. And now if we graph. Right, we can hopefully get a better, there's 1, 2, 3, nope, we don't make it in, and that's going to be it. So we have 1, 2, 3, so the answer is A. For problem number 7, the derivative of f is given by x squared cosine of x squared. How many points of inflection does the graph of f have on the open interval from -2 to 2? Alright, so an inflection point happens when f prime changes from increasing to decreasing, or vice versa. Alright, so again, this is why it's so important to know your derivative connections. Okay, so I'm going to go back to y equals. You can see I've thrown y into y3 this function. So what I'm going to do is going to turn off the first one by hitting enter on the equal sign, turn on our new equation, and we're interested this time in the interval from -2 to 2. So back to window, -2 to 2, and zoom, fit. And this time we want to see a change in increasing, decreasing, or vice versa. Alright, so that means we're looking for like maxes and mins. Okay, so we've got 1, 2, 3, 4, 5. So the answer is D. Okay, so that takes care of the 2 calculator problems, and we have one more with no calculator. The graph of f is shown in the figure above. Which of the following graphs could be that of the derivative of f? Okay, so what's happening? We have a function which is increasing and then decreasing with a relative max right about there. Alright, so we want a derivative which is going to be positive and then negative. Because we need our original function to be increasing and then decreasing, so the derivative needs to be positive and then negative, and we need the change to happen right about there. Alright, so we see a graph here which is positive and then negative, and the change happens right about the right time. So A is definitely a candidate. Let's take a look at B. B is always positive. So therefore, we would want an original function that's always increasing, which is not the case, so B is out. C is negative and then positive, so we'd want a function which is decreasing and then increasing. That's not what we have here. And then D is positive and then negative and then positive. So if the derivative was positive and then negative and then positive, the original function would be increasing, then decreasing, and then increasing. And that's not the case. So our only good answer is A.